Okay. Oh, what's going on? Okay, so 4.2, parallel and perpendicular lines. So what we're doing now is we're going to be comparing two lines, right? So in the last lesson, we were talking about slope, right? So that was all about y is equal to mx plus b, right? And we're looking at the m value, right? So we're looking at that slope. So if we had two lines here and they were parallel, right? So if we've got like this line, and they had exactly the same slope. So in this case, rise of 7, run of 5, rise of 7, run of 5. So the same m value, the same slope. You guys see that those things would never touch, right? That those lines would be parallel? Yeah, so that's the idea. So that's our first line with parallel lines. If they have the same slope, then those things will never intersect. Okay? That's step one. So then we're going to do perpendicular lines next, and that'll be this lesson. So let's do this question. So it says line EF passes through the point E, -3, -2, and F, -1, 6, and then C passes through those points, AB passes through those points, and it says sketch lines and calculate the slopes. And we're going to see whether or not they're parallel. So we got to make a Cartesian plane here first. So let's make it like there. Yeah. We're gonna make our y's go up by 2 every time, right? Like on the y-axis, so we can like actually get them all. And I think we're good for our x. We'll be a little off on that side, but that's all right. So we'll go up. So that'll be 2, 4, 6, 8. It's like -2, -4, -6, 8. And then we'll just go up normally by 1, 2, 3, 4, 5. Okay. I'll give you a second. All right, so let's plot some points. So let's plot E. So that's going to be at -3, -2. So right there. So it'll be E, and then F will be -1, 6. Okay, and this is a line, so let's actually just connect them. All right, and the next one. So -1, -3, so that'll be right there. Oh, sorry, I should label F on the other one. So that's F. Okay, and that'll be C. And then D is at 1, 7, so right there. Oop. Okay, and then one more.
Wait, that was D, right?
Yeah, and that was D. Yeah. Okay, and then we'll do A is -3, 8. So up there. And then this one's going to be off the page a little bit, but -5, so like over there, and then down 2, so like there. So that was A, and that was B. All right, so now they look kind of parallel-ish, don't they? Yeah. Yeah. But we can't know for sure. Like they might be off just a little, right? So what you could do, you can always just make a triangle, and you can figure out what the rise and what the run are. But you know, I think what's we can even do without even those is use our equation. M is equal to y2 minus y1 over x2 minus x1. We'll start getting used to this more.
Could it be also y, like change of y and change of x?
Yep, they'd be the same thing, right? Changing y over changing x, yep. Which really just is rise over run, like making the triangle, right? Okay, so I like to label them on the picture here too. So in this case, our x1 would be this one. So x1 and y1. This would be our x2 and y2. So now we're just going to throw those into the into our equation here, right? So m is equal to y2 is 6 minus, and then just careful on this one because it's 6 minus, and then y1 is negative 2. So it's 6 minus negative 2 over, and then x2 is negative 1 minus, and then x1 is negative 3. So the slope on this guy would be 6 minus negative 2. Yeah, right? Minus a negative is the same as adding. So that's the same as 6 plus 2. So that's 8 over. And then negative 1 plus 3 would be 2. So 8 over 2. So that is 4. Okay? So that one's 4. So now we move on to the next one. So the next one, m is equal to thanks, y2 minus y1 over x2 minus x1. And again, here this will be our x1 will be the first one, y1, x2, and y2. So m is equal to, so y2 was 7 minus negative 3 over, and then x2 was 1 minus negative 1. So m is equal to 7 minus negative 3, that's like 7 plus 3, so that's 10, over 1 minus negative 1. 2, yeah, because minus negative is like plus, right? Yeah, so this is the same thing as just 1 plus 1, so that's 2. So that's the same thing as 5. Okay, so right off the bat, are those two lines parallel?
No.
Nope, they don't have the same slope. So even though they're close, right? One rises 5 and then over 1, the other one rises 4 and over 1, so they're not going to be parallel. Okay, and then just the last one. Let's see if it's parallel to the other two. So what color is that? Green. So m is equal to y2 minus y1 over x2 minus x1. So the slope is equal to, okay, we'll label them again, x1, y1, x2, y2. So this will be negative 2 minus 8 over, and then x2 is negative 5 minus negative 3. So the slope is, so negative 2 minus 8 is negative 10. And then negative 5 plus 3, right? Because this really ends up being like plus, so this will be negative 2. So what's this? This will be, yeah, negative divided by negative. Those are going to be positive 5. Right? So looks like which two lines are parallel? Right, so this one and this one are parallel, right? The purple and the green ones in the end. So this and this are parallel lines. Okay. Moving on. Okay, perpendicular lines. Now, so this one just requires one extra step. We just have to memorize what it is, like how the slopes are related here. So if you can see, like on this graph over here, that if these lines are perpendicular, right, so they form right angles with each other, like those would be perpendicular lines, then another pattern, or a pattern shows up, and that's, so if you look at this line, it has a rise of 4 and a run of 3. And if I look at the other one, it has a rise of 3 and a run of 4. I wish they would have drawn that a little bit different too. I would have considered that down 3 over 4, like drawing the triangle different. But either way, what ends up happening is that one of them, if one of them is 3 over 4, the other one is negative 4 over 3. Do you guys kind of see the pattern with those? So if this was like the slope of one and that's the slope of the other, like M1 and M2. Do you guys see like what the pattern is going to be here?
Yeah.
Kind of, yeah. So they're called inverse or negative reciprocals. is what it's called. So they're reciprocals because you see how this one's 3 over 4 and the other one's 4 over 3? And then one's negative and one's positive. So they're negative reciprocals of each other, or a negative inverse. Okay, so let's do some examples. Yeah, you guys can read through this one too. So it just kind of talks about vertical lines and parallel lines, but I think for the sake of time, let's move on. So -2 and 5. Okay, and -5. Okay, so let's go. Let's make our line there and there. So let's plot the lines. So the first one here, so it'll be -2 and 7. So I'll just kind of go off the grid for a little bit on these ones. We'll just get the right idea though. So this will be -2 and then up 7. So that's 5. So 7 would be like up there. So that'll be S. And then 2, -5. So down there. That'll be T. All right, and then the next one will be at -2, 3. So -2 and then up 3. And then 7. And so from there and then 5. This will be up to like there. All right, so now the question is, so are these two lines parallel or perpendicular in either? Well, first off, just looking at them, do you guys think these are going to end up being parallel? No, they're not parallel. They could be perpendicular, though. Like, it could be the case that this is a right angle that's forming in there. So what we're going to do, again, we're just going to find the slopes and then just see if they really are that negative reciprocal. Okay, so same thing. We're just gonna put them into our equations here. So m is equal to, so this will be -5 minus 7, right? I just went y2 minus y1 over 2 minus -2. So the slope on this guy, so 5 minus 7 would be, yeah, and negative, yeah. So -12 over 4, yeah. So then that can simplify, so -12 over 4 would be -3. Or 3 over 1, if you want to write it like that, so you can still think about it as down 3 over 1, right? It's fine when we're doing slopes to write it like that, or -3, that's fine. Okay, so that's one of them. So now the other one will be 6 minus 3 over 7 minus -2. Okay, so 6 minus 3 is 3. 7 minus, so that's going to be 9. So what does that simplify to? 1 over 3, yep. Okay, so the question is, are those negative reciprocals of each other? Yep, they are, right? You guys see that they're flipped upside down. One's negative, one's positive. Doesn't matter which one's negative and which one's positive, but one's negative, one's positive. Okay? Okay. Okay, so this one says we've got E, F, G, and H as a parallelogram over here. Is it a rectangle? So if this thing really was a rectangle, then the idea is a rectangle would have 90-degree angles in all of the corners. So in order for that to be true, what that means is that this line should be perpendicular to this line. You guys kind of see that? And parallel, yeah, this one should be parallel to this one. Yeah? So really, we just got to find the slopes of these things. Now, again, we could use the slope formula that we just used, but this one, since it has the graph, we could make some triangles here too, right? If I want to figure out the slope of this line from like here to here. I could draw like a little triangle there. This thing has a rise of like -1 and a run of 3. So EH, line EH, has a, what's an arrow? A slope of -1/3, right? Rise of -1 or decrease of -1 and then a run of 3. Okay, so let's look at FG. So FG goes down 1/3. It's like -1 and 3. Okay, so FG has a slope of -1/3. Okay, so that one's looking pretty good. Those lines definitely are parallel, right? E and H and F and G are definitely parallel to each other. Let's figure out the other ones now. So now we're looking at. So now we're looking at E to F, right? So let's go from F to E. It'll be a little bit easier to think about this. So this one goes over 2 and up 5, right? So over 2, up 5. So let's write that down. So FE has a slope of 5/2, yeah. And then we just have one more line to figure out here. So last line, what color should we use? Nope. Yeah. Okay, so the last one, G to H here, is going to go over 2 and up 5, right? Okay, so GH has a slope of 5/2. So what do you guys think? Is this thing a rectangle? Yep. So is it a rectangle? Yes, it is. How do we know it's a rectangle? Yeah, because, well, yeah, those are parallel to each other, right? These are parallel to each other, like however you look at it. And they're perpendicular. All right, so sorry guys. Let's look back at this again. So this one and this one are parallel, right? Those are parallel. This one and this one are parallel. So that's good. But this could be like a box, right? If you had a box and then it like tipped over sideways, like it wasn't a very stable box, those still would be parallel to each other, but they wouldn't be at 90 degrees to each other. Right? So how do I know that this one isn't at 90 degrees with this one? Well, yeah, the slope on this one, right, from there to there, for E to H was -1/3, and the slope on FE was 5/2. So those aren't negative reciprocals of each other. This, if they were, just like we should have expected that this would have been 3/1. Right? Then it would have been a rectangle. Then it would have made a 90-degree angle there. What's that?
No, it's
Yeah, so this is not a rectangle. Yeah.